Welcome back, trainers, to this video. And in this video, I'm going to be talking about the introduction into the world of PLC programming. So this is a two-part series actually. In this first part, I'm going to be talking about the hardware module, and the next video, I'm going to be talking about the software module. That is generally be focusing about the actual programming of the PLC. So my name is Wilfred and I work at Avic International. So let's begin. So in this course, I'm going to be focusing on the following topics generally. We are going to kick off with an introduction into the world of PLC. Second, we are going to go into the safety that is generally followed when you're working with PLC. The third is a PLC hardware overview. Fourth, we are going to go into inputs, outputs, and finally we are going to use a demonstration board to generally show how all these parts come together. So somebody might wonder what exactly is a PLC. It is generally a computer as such, because it receives some form of input and processes that kind of input data to produce a certain result of the expected action. Generally, it is an industrial computer. It's a computer designed to work in rugged areas, generally in a factory or an industry, that it's been purposed and adapted for the control of manufacturing processes such as assembly lines, machines, robots, and robotic devices, which require high reliability, ease of programming, and fault diagnosis. Those three parts are, or those 3 points are the most important. It is highly reliable, ease of programming, and fault diagnosis. Means that once it has been programmed, it is expected to do that similar task for very long time. So very, very reliable, and given the conditions which are in a factory, which might be very difficult for any other computer to survive, PLCs have shown quite a remarkable reliability over time. And also, ease of programming is you should be able to quickly give it the programming instructions you require to conduct, state the inputs that you have, and state the outputs devices that you also have, so that you can be able to quickly write your code or write your ladder diagram, so the PLC can be able to do that for a very long time. PLCs have been known to work even untouched, unless there's any other issue such as a power failure. They normally are reliable for a very long time. Fault diagnosis is also very important. Means that should there be any problem that should occur in the PLC, it should be very easy to identify where is a fault. Normally, even on the PLC that we are going to use now, there is an LED supposed to indicate when there's an error or a fault, so that you can quickly solve the fault and the operation can continue. Now, safety is very important when working with PLC. Reason being is PLCs need to be powered, and once a PLC has been powered and has been programmed, it is going to send instructions to the output device. Mean that output device can be anything. Maybe it's connected to a contactor which is connected to a motor. So all these steps must be carefully followed, such that if a PLC has an input mains of 240 volts, that is very, very dangerous. So care should be taken when working with such power. Also, during debugging, isolate the PLC to avoid causing accidents in the production line. This is what I've just said. When a PLC has a fault, you isolate the PLC to identify where the fault is. Don't debug or try to solve the fault when the PLC is connected to the output device. Reason being is you can, as you're trying to debug the problem, write or programming write instruction to the PLC which could cause an accident to the output device because maybe it is not connected correctly. So it's very important that when you want to do any form of debugging, you should isolate the PLC from the production line. Third is always read the manual. This is something that I've always stressed in all the videos. Always read the manual. All PLCs have a manual. if you are in any doubt or any question before connecting that PLC to power, read the manual, read the specifications, know what the manufacturer has intended that PLC to work with, and which power environment should be able to work with, and always consult before embarking on repairing PLCs and other peripherals. So if there is any point of doubt, you have checked the manual but it's not clear, always consult an engineer or specialized person to be able to help you to be able to get this solve this problem. This also affects also the equipment that that you have in your schools. If you're in doubt, always consult AVIC engineers to be able to help you solve this problem. Now, third, we are going to focus now on the hardware part of the PLC. So we're just going to look at it from an overview perspective. And if you look at this photo here, this is the PLC that we are going to use. We're going to use a Mitsubishi FX1S 30MR-ES or /UL. It's quite an old PLC, but at the end of the day, it's quite reliable. It has been working for a very long time, hasn't given me any issues actually, and it receives all its inputs and processes the instructions, gives the correct outputs for a very long time. So I've had it for a while, and I can say it's been quite reliable. So this PLC that I'm going to use for demonstration has 30 inputs and outputs, as you can see here. Amongst these, we have 16 inputs and 14 outputs, so they are not matching. So we have 16 inputs, that is inputs up along this section here, and 14 outputs means that the outputs are below this section here. So my PLC is a relay type of PLC, and this is what we are going to use for this video. This is a relay type of PLC, and that is the reason why you see this R here, 30MR. The R represents the relay type of PLC. It's a 24 volts sync source. That means you apply 24 volts to be able to, for you to function correctly. Its a power source is AC 240 volts, which is applied at this part. You have the live and the neutral, and that is where you apply the power. So you have to exercise a lot of caution when you're working with this type of PLC. The program capacity is 2000 steps. So when you're writing the program for the ladder diagram, it goes 2000 steps, which is quite a very long program. The memory type is an EEPROM, that is electrically erasable programmable read-only memory. And the timers we have on this PLC is a 3 type of timers of 64 points. We also have counters, 3 counters of 32 points, and the capacitor memory for this PLC is only 10 days. So generally, the capacitor memory recharge takes around 30 minutes as soon as you connect it to power. So next, we're going to look at the PLC input specifications. So as you can see in this diagram, we have an FX1S 30MR type of PLC, and this part here shows the input side of a PLC. Generally, unless otherwise stated, you'll notice most PLCs will have their input sections at the top and output sections at the bottom. But as I say, always ensure that you consult the manual before attempting any connection to the PLC. So when you look at the input side of this PLC, it's 16 inputs. That is, you'll notice it runs from X0 till X17. But generally, you notice it's 16 inputs from X0 to X17 because you don't have 8 because PLC run on an octal number system. The input voltage is 24 volts DC. Input current is 7 milliamps. That is this 7 milliamps works between X0 to X7. That is the input point X0 to X7. The input current that is now for X10 to X17 is 5 milliamps. And then the input switching current is normally greater than 4.5 milliamps, and input switching current, that is also there now for the second part of the X10 to X17, is greater than 3.5 milliamps. Generally, we have a variable response time of 0 to 1.5 milliseconds. So now when you talk about input devices, what do we generally mean? PLCs, just as we discussed when you're starting this tutorial, is they have inputs and outputs. Inputs is any device that gives or changes or cause to change state of a certain type of an output device. And for this, we should be talking about anything that deals with switches, push buttons. We have sensing devices, which maybe like the ones which sense movement or sense an object before it. We also have limit switches, that is for moving devices. Proximity sensors, that is for anything that is around a certain proximity of a certain device. We have photoelectric sensors, condition sensors, vacuum switches, also temperature switches. All those are classified as PLC input devices. And here in my demonstration board, I have push buttons and also selector switch to act as input device. Now, PLC output device specifications generally, or output specifications, now we focus on the output side. When we are starting this tutorial here, we saw the input sections here. Now these are the outputs. So as this PLC, the outputs are below the inputs. So always check the manual to confirm this fact. The outputs for this PLC are located here. And you notice all now the wires for the output devices have been now connected across the output terminals. It's an FX1S 30MR Mitsubishi PLC. So our outputs are 14. Again, from X0 till X15 is our set of output devices. Of course, skipping number 8 because it's an octal number system. And the output voltage is 24 volts DC and an output current of 7 milliamps. This output current now ranges from X0 till X15. So what kind of output devices are we talking about? They can be so many. In fact, what I've listed here is generally what we classify them as output devices, but PLC can control pretty much anything. Pilot lamps, we have valves, we have motor starters, horns and alarms, stack lights, control relays, pumps, printers, fans, name it. There's so many. And you notice one thing about PLC output devices, because if you look at these output specifications, my output for the PLC can only power 24 volts and 7 milliamperes. That is the current. So you cannot directly control or connect a motor to the PLC output. No, that is dangerous. You're not supposed to do that. Always, if you want to connect a motor, you connect the PLC to now the motor starter, so that the PLC can control the motor starter, which will now be able to control the motor itself. So for this that is demonstration, or for this video, our board will look like this, and we'll be able to now to go through each section to be able to see how now they all come together or work together to be able to now give a demonstration, so that you see for yourself how the PLC works. So now this is our demonstration board, and I'm just going to quickly just go through these individual parts, but later onwards we are going to now see for ourselves how all this work to be able to just to make us or give us an understanding how our PLC works. So here we have that is our power, this incoming power. This is a safety device, and you have the PLC, the Mitsubishi PLC here. We also have our inputs to the far right. Now the 3 push buttons and 1 selector switch, and then all that is connected to the PLC to produce our outputs. Our outputs are quite easy or simple. As a matter of fact, it's just pilot lamps. We have a red, yellow, green, and blue. So we are going to now use now the inputs through the PLC. Now for the software side of the video, or the next session, I'm going to now show you how to write the program here to produce the kind of output that you want. So that is basically how this video is going to work. But I would also want to show you how to power this board, how to know which type of voltage to give it so that the PLC can be able to work correctly. So now we are going to power our board using a desktop power supply, and as per what we had read in the starting, always make sure the voltage is correct. We had agreed that we need 24 volts that is being applied so that the PLC can be able to switch and control the outputs that we have. So now I'm going to set the voltage correctly to 24 volts, and I'm going to set the maximum current to 1 ampere so that the power supply can give this power to the PLC to work correctly. So now this is the AC power. It goes to the circuit breaker, which is connected now to the PLC. Now at this point, now we are sure that our PLC is turned on because we have power. You can always lift this flap. Let me see whether I can zoom clearly to show you where the terminals are connected, but I'll put a link to the manual so that you can see which terminals you're supposed to use and the outputs to now our pilot lamps. So I don't know why that focus is like that, but anyway, moving on, you make sure you always drop that flap for safety purposes. So now this is generally the board that we are going to use for demonstration purposes. This is the PLC in the middle. Now I think this view gives us a better understanding of how now this videos or this board works. Of course, we have our PLC here. Then to the far right, got a set of input buttons. So you can see this how I've connected the input buttons to the PLC: stop, start. You can name these buttons anyhow you want. Select a switch. All of them are connected to the PLC, and then they come out here to the outputs: red, yellow, green, and blue. So this connection now is what gives us an understanding of how a PLC works. It's a cycle process. Then once it's processed, it goes out to the outputs. Remember, that process has to be followed like that. You press any button here, the signal goes into the PLC. The PLC now, through the programming, produces the output that you expect. So it has always to follow this cycle. There can be a feedback, but generally this is the cycle that it works. So output can be anything. Just as I had stated before, it could work from motor starters, anything. But as long as you follow that sequence when you connected your devices correctly, the outputs will obey what the PLC is telling them to do. You interact with the PLC by pressing any of these buttons, and the PLC, through the programming that you've given it, will work. Now you see this device here. This is a timer. At the moment it's not connected, but the timer is what assists. You can be able to program an output or have a timer-based type of a system whereby a process is run depending on the time that you set. But essentially at this point, it is a relay that it's a very handy relay that comes so much, especially when you have so many devices that you want to control at the same time. Relays are a safer way of connecting your devices to ensure that you can be able to turn on and off any device, safely turn on and off any device that you have. Okay, so at this moment for this circuit, I've not connected the relay because it's a 24 volts type of relay, but in the subsequent video, once we start writing more and more complex that is ladder diagrams for this PLC, I think it's going to be quite important that I can be able to connect this relay so as to have more and more output devices, or even more input devices, not just having the push buttons, but more input devices will be able to help us be able to understand PLCs better. Something very important is this circuit breaker here. Always ensure that you have a safe way of turning on and off power for the PLC. You could use a switch, but I thought a circuit breaker will come more handy and also more safer way when working with high voltage. Remember, the first topic that we covered was safety, because safety is very important when working with PLCs. So ensure that anywhere that you have are safe and any connections that you have are very safe. So also you need to know how to connect your output devices. That is how it should be powered on. So now let me power it on. So you can see I've turned on the circuit breaker, and then the PLC will turn on automatically. Given the code that it has already, the programming code it has already, you can see it's already responding to the program it has. It's going to run through the whole program, just as I had told it, and all the lamps are going to come on. Also, something important is you do not necessarily have to look at the outputs, because the PLC has its own type of LED output display at the PLC itself. So to show you how it works, so let me press this reset button. Let me dim off the lights so that you can be able to see clearly. See, the red lamp has come on. Next you're going to have orange or amber, and then the program just runs on. It turns on the green lamp, and then finally the blue lamp will turn on. All these have been programmed at a set time. That's how the PLC works. Define time intervals between all your steps or all your outputs, so to have a program run over and over again. So you can press at any time. If I press the red button, it is going to reset the whole program, because the program is here inside. Depending on which type of button I press here, it all responds to the output that we have here. So it's a very simple, actually it's a very simple program. I do it once more, and then the program restarts. All this is built inside the PLC memory, that it obeys what you tell it to do. Once the PLC is connected to the computer, and then you write your code, it responds. Again, I restart the program. At this point, if I press any button, it won't respond to that, because I've only programmed it to work with the first stop button. That is a red button at the first, because that's my first button. In the program, I'm going to tell the PLC when this button is pressed, you're going to reset and start all over again. So even if I press the other buttons or turn the selector switch, nothing is going to happen, because they've not been programmed for that. So I think I've gone quite in depth of what I wanted to cover for this video. So I think I'm going to leave it at that point. And if you have any questions, remember you can just put them at the comment section there below, and remember to like and subscribe. So in the next video, I'm going to focus now on the software side of the PLC. That is now the programming the PLC, because that is now what essentially is the weight behind PLC. So thank you so much for watching, and we'll meet in the next video.